this video we're going to see how our robot can detect a black line on a white surface using this grayscale sensor, where then we can use it so the robot can track a line or drive over a line. This has a lot of application, and using this you will learn a lot of principle of robotics. Hi, welcome to a product tutorial by Robojax. This is SunFounder's PiCar-X Raspberry Pi self-driving robot car kit.
Hello friend, how are you? Turn left gear. Count down to 3 seconds. 3, 2, 1, rock. I lost.
To get to the documentation, go to docs.sunfounder.com. From this screen, scroll down until you see robot kits. The first one, PiCar-X car kit version 2 with battery. Click on it, and from here click on the left side, Python, and we will see all the codes. We can run the code either from the terminal where we log in. First, let's check our robot if it is connected or to the Wi-Fi or to the network. Ping -4, that refers to IP version 4, and then the host name robojax.local, and enter. It responded and we got the IP 192.168.0.102, and make sure that your computer or devices that you are checking the ping must be within the same network. So it is connected to the same network. That's why I can ping it here locally. Clear, and we can now SSH Pi, connecting via SSH, add robojax.local, and it asks for password, and I got connected. Pi at Robojax. This is one way to run the command line and program. Another tool here from it's called SunFounder's Create Agent. When you click on the start and type Sun or SU, you will see SunFounder Agent. I have shown it in the previous lessons how to install it. Please watch the lesson number 2, I believe, or number 1, which I have shown it. Let's click and open it. It will be available. Now we can click connect here, type the IP address, the username and password for the Raspberry Pi, which I have explained it in the first lesson. Now we got connected. As you can see here, this is the same command line that we have here, but this one has advantages at the moment. So the first thing, this is the code. We are typing cd, which means change directory. We are going to this directory and an example, and then we will run this code called minecart plus.py. So using sudo and Python 3. Sudo is a super user do. So we asked to execute the command as super user, and I will move this to the right. As soon as I move it, the terminal goes at the bottom, so you can see the robot here. I'm just holding it from the ground up, and here let's run this code. When I click, it runs. So this is not detecting anything, that's why it's just rotating. And these sensors which are below this are detecting, and it causes the wheels to change the direction. You see? So, and let me stop it. So one of them is running, even though I stopped it, interrupted, stop again, nothing. So it is running. Let's see the code here, and let's run this to stop the car, stop the robot. I cleared everything which doesn't do anything. No, I forgot to remove the PiCar-X, so that was PiCar-X up to here. Now this doesn't do anything. Let's run it. So finally the car was stopped. So now let me show you this code and see what is inside it. So I'm going to this folder and running this. Let's go to the terminal. I'm changing the folder by typing cd, change directory, p. I just press tab and then ex and then tab. It goes to that folder. Every time you want to know the location of the current folder, just say print working directory, pwd, and enter. It will print the full path for you. This tilde is an alias for this portion, pi home. You see, if I want to go back, cd dot dot cd space dot dot cd space dot dot. So this location, if I type it print working directory, it says it's pi home. So that tilde is a shortcut, an alias for this, not a shortcut, so it will make it easy for us. Clear. Let's go cd pi example and then dir. I type dir, it gives you the list of directory, and here this was the file. Let's open it and see what is inside it. To open the file, we type nano. Nano is one of the applications. You can use different tools. Nano and then min. I press tab. It will be auto completed. Press enter. Here is the code, and there are some explanation here. The cursor is in here. We have to go with the arrow down to see it. Like the rest of the code, we are importing this module and this class, and we create an object called px, and this is the current state. If the text or not, it will be stored in this variable. At the moment it says none, and then px power, the power of the movement of wheels. The offset is 20. The date is stop. And this is the method. Let me go down. This is a method that it has these variables, global, state, and then current. When you type global, it's referring to the variables that are outside, so they will be available in here. Now we have else if. If the state is equal left, we will see where it's being updated. Then we set the direction, because the robot will be moving on the left. If the robot is on the left of the line, for that reason we turn left and go backward with a power of 10%. Otherwise, else if it is right, then we turn to the right and backward, so the car moves to the left. So this is the out handle. The job of this one was when it is out, and then while true means forever, run this, all of this up to here. So first we get the grayscale value which will return a value that is we set for 1000 for the white and 500 for the gray. We did the calibration on the separate video, and what the value will be stored here as a list, and then get a status from this list, and it's called GM status, grayscale module status. And this is just printing the value that's getting from here, with formatting it with this percent and s as a string. It will be the first one, and the second one is the state, the values. And so we are storing this in a variable called current state, and we check if current state is not equal last state, then we will break. If it's not, which means if it is the same, we will exit from this, and it has very short sleep time. And then we have another method called get status. Let's see what it does. We get the status using get line status with a value of the line that is coming to this. It will read the value, stores it in the variable called underscore state, and then if underscore state has 3 value of 0, 0, 0, this white paper with this line, and I'm going to place it right at the middle where the middle sensor is on the black area. And let's read the value. As you can see, we read 1500 and 1400. So this is 1400 or 500, 1500, and the middle one is around 500. So this is very good reading, and from this we can see the status 0, 1, and the middle one it shows 1. Let me move this, so I go to the right, and the right should be on the black area. Now you see, so this means right, left, so we are starting from middle, left, and then right, and the value is around 300. Now if I go to the other side, now it shows that the car is, so the first one, now this is the 0. Let's have a look at the code. If 0 is 1, it means the car is located on the right side, which is true. Our robot is now located on the right side of the line. When it will be on the left side with number 2, if this is equal 1, if this portion, then we will be on the left side. Let's check it. Exactly. So you can see this, and based on the status, you can decide what to do. It means it has stopped, and if it is equal 1, it will be forward. If it is, so the index 1 is equal 1, it means it's forward. If index 0, because it's array or list, it is 1, then it will be right. If it is 2 if equal 1, so you see they're all 0. If they're equal 1, 1, 1, for different index, we have a value returned from this method. Now let's go to the main. So this is checking if the main file that is included part of the main code. It says while true, which means forever run all this. So we are getting grayscale data as a list, GM, and then GM status is requested with this value. This value goes to this function, to this method, and we get GM status, and this is also printing it, and this will just print the array. So this says a GM state, and this is printing the text formatting, and we have also printing the actual array of value 0 with the last state. So this is interesting. Unless you draw the diagram, you will not be able to easily understand it, but if you look at it 2 or 3 times, you will understand. And then the GM state, again, if it is stop equal, if it's not equal stop, the GM state is equal the last one, because it's not the same, so the last one will be the same. Otherwise it will be forward, left in terms of angle. If it is forward, we turn the servo or steering to the middle. and then with the power of px, which is explained at the top. If it is on the left, then we set the offset, which means 20, so it moves to the right. If it is right, we send the offset to the left, minus 20, so this is going to the left. And then else, if these states are not true, it goes to out handle. Out mean out of the line, and then out handle is explained here. So let's go back. Now remember, get status is also the one that I explained. This one was going to that method. And finally stop, and then it will print the text, and we have 0.1 second or 100 millisecond sleep time. Let's see what else we have at the bottom. Nothing. So this is the code in here. Let's see what is the difference between this code and the code that we have in here. I've changed this, I attached it, so easy, just click reset. As you can see, there is no method. The code that is here is different. We can just print it on the screen. So power while true, this is reading the grayscale and this is printing it. Now let's delete the rest of them, because the motor, we don't want the motor to run like this. So we are getting the grayscale value and printing it, and this is get line status. This is a function or a method from within the PiCs, and it will get the status and print it. Let's run the code. So it is printing. Let's add some delay because it's printing it too fast. Import time, and then now we can say time dot sleep. Let's have it like 0.1, so every 10 times in a second, and then run the code. Stop, and it stopped work. Let's run it again. Now it's working. So I had to stop it and then run it. Now these are the values. So the status was this code. They have included here. This is 0, this is 1, this is 2 in terms of index. Index 0 is here, it means right. And then this is 1, index 1 means forward, and then the 2 is left. So stop, right, left, right, and forward. So we have 4 stats. The value that you see here is the status for the robot. So GM mean grayscale module, and it has been explained a little here. Now let's run this code. I'm typing sudo python3 and then this file name, minecart plus, and let me I'm holding it up and pressing enter. Let's see. So I'm pressing enter. Let's see what it does. So the robot is going forward, and if I'm not going to put it, I'm just going to put it on the surface, and you see. So as soon as I go to the left, you see, it is. If I go to the right, it doesn't. So let's see what it does. So if it is to the right, it goes to the left. So let's go and see it on the floor actually. Now I'm going to show you how to run that program when the robot starts. First, let's make a copy. So let's say dir. So this is a file, minecartplus.py. Remember that? I'm going to copy this to the Robojax folder. So I'm going to show you first. Let's see cd, and here now I'm in the main folder, parent working directory. You see I'm inside home pi, so this is a tilde. dir list means, so we have Robojax folder. Now I'm going to copy that from this location to this location, to the Robojax, inside Robojax. So I'm typing cp, which means copy PiCar-X example. It's completing it for me by pressing tab, and then mine, like that, and then space destination name. Now we have to type the full, for example, like that, and then Robojax, and then the file name. I'm gonna call it line.py, and then enter. Now it has been done. Now let's go and check it if it is there. cd Robojax dir, and you can see line.py is there. Now we are going to do the scheduler and run the code. Sudo cron tab -e, which means edit. Let's go down. This is my cursor. I'm going with the arrow down, uncommenting this, and then at the end I'm gonna say line.py, and press O to save it, enter, and then to exit, Control X. That's done. You can reboot the robot by typing sudo reboot now. So the light is now blinking. Before going on the floor, I want to see it, if it works. Okay, started. So perfect. Now turn it off. Here is a sheet of white paper with line. The line is about my finger, about 12 millimeters or 15 millimeters. Let me turn on the robot. Waiting for this. As we hear the sound, so it's supposed to move now, and when you see the light turn on, I just realized that this is not moving unless I left it, because the power is very low. You see, it's running now. If I put it, it will start working, but that's not good. So this is working very hard here. Now away. Now let's put it in here. Let's see if we can. So it needs some tweaking and fixing. And also, let's see if it goes to the right. You see, already lost. So this is the hardest part, I believe, when there is a lot of curve. Let's try it on the other side. Now let me put it on the other side, which has very thick line. This is very sharp turning. Maybe it's hard for this robot, but struggling. Now this is very tough here. Maybe it will. I gotta grab it and turn it off. So it needs a lot of work, but the whole principle is working perfectly. It detects the line. It just needs matter of programming, so you can play with this. And thank you for watching. I will see you in the next lesson.